prelims part. Now, the moment when you talk about I'll be talking directly rather than having more video or complete 1 year. Here, with more specific, the physical geography, geomorphology, parts, and so when we talk about geomorphology, what do you conclude from geo? What exactly is it? Very fast? What exactly about geo? Because that will give you some idea what has to be. Now, before this, have you completed class 8, class 9? They are very, because directly then they put statement wise. What do you mean? No, it is not a hard and fast rule. Try to speak. Whether it is right or wrong, correct you. Where you can correct yourself. Process of not checking your, because learn here may be bearing best for term geom fast. Okay, that part then. Perfect. When we talk about geomorphology, knowing that this geomorphology talks about changes, evolution of the earth. Evolution. Geo means earth and morphology means morphology means. Now, change always accompanied by forces. Only forces can change. So hence, always affected by two. The one force which is acting from within or inside the earth, and the one force which is outside the earth. Refer that as exogenetic. Genetic means endogenetic, exogenetic. So hence, in geomorphology, talk about changes. We always talk about the two are referred as endogenetic and exo. Two forces are. The changes which occur on the earth are generally referred as self, simultaneous. It is not simultaneous. And these are gradual, takes millions of these changes. They are simultaneous. What do you mean by simultaneous? By itself, baby when it is hungry starts crying simultaneous. Simultaneous. And it is gradual process, millions of years. Now, can you give example of endogenetic impact? Volcanoes, earthquake, then plate tectonics, movement of the plate. Right. So those are called as. What do you mean by exogenetic? Any example? That is extraterrestrial. Sun is their source of energy. Sun is the sun is responsible for winds, bursts, water, glaciers, which are. So these are referred as. Now, when the wind is blowing, it is responsible for reducing some impact. It will reduce the rocks. Water carries them. River carries them. Glacier also carries. So we refer them as exogenetic forces. Now, endogenetic forces and exogenetic forces are they acting separately or they acting at a time? Both are simultaneously acting on. When the earthquake is there, can we say the rivers have stopped? Winds have stopped? The endogenetic forces are occurring at the same time, exogenetic. So they are simultaneous, which are responsible for changing a big rock into small rock, that is mountain into smaller. We refer them as landforms. Now, generally in geography, landform means when you say this podium is having particular shape, chair, it is having particular table, it is also having a particular, but all are made up of plywood only, all are made up of wood only. So why we call it as a podium? Because of its shape and structure. Why we call that as a chair? Because of its shape. It is also made up of same plywood, but we refer that as a chair. And table, the same plywood, but still we refer them as a table, even though their content is, their material is, name them separate, that they should not be classified in one. Segregate. The same way, when you talk about mountains, plateaus, do you think that they are made up of separate structures? So hence, to differentiate mountain from plateaus, them by land, mountain, hills, and all these landforms, they are not permanent. They keep on changing. That is called as geomorphology. Changing the landforms on the surface. Mountain is a land, valley is a land, plateau is a land, desert is a land, hills are land. All relief, all relief, which are having particular shape, size, and they also have their evolution. When the, if you say Himalayas, so can we say Himalaya was formed 10 years back? So it means every landform will have its own. Every landform will have its own. Right. So hence, these landforms, they are not permanent. They keep on changing. That is the core of geomorphology. So means morphology means changing of the landforms like mountains. These are referred. And what is the genetic and this is simultaneous. So this process, is it going to stop? So hence, this geomorphology is static or dynamic, because Earth always keeps on. So this is responsible for creating many landforms, like new plateau is, new island is, a volcanic structure destructing. So hence, generally see dynamic, but it takes millions of years continuously. So hence, this is to be kept in the mind on genetic. Now here, one more thing is endogenetic forces always disturbs Earth's surface. Endogenetic forces always try to disturb. And what is the role of leveling the topography? Exogenetic force does leveling of topography, means breaks the big rocks, transports them, and then deposit them. So we refer that as work of exogenetic transportation, deposition, and before that, weathering, that is breaking up of the rock. So this you should. And what are the two theories you are? One is plate, that is for main continent, plate tectonics, and some rough idea. So when you are reading what is how these, what are endogenous, what are exogenous, what is, which theory is ask concepts, mark them. Now, when we talk about this exogenetic forces are also referred as forces of denudation. Have you heard? Denudation. Exogenetic forces of denudation. Sometimes when they ask, denudation includes weathering, transportation, and in between you may have mass waste. Very careful when term denudation, the work of exogenetic force, leveling of topography, how it does label, reducing big rocks, weathering, transportation, and depositing. That is the ultimate work of or denudation. Now, what are agents of denudations? Rivers, winds, glaciers, groundwaters, and waves. So these are the 5 agents of denudation you have to read. Now, when the river is flowing, it will destroy some lands. It will create landforms. Simple as I'll explain. You are having a big made up of wood. Now, maybe after 50 years, the edges have destroyed. Now, you will convert the dining table or so when you are sitting on the study, can you say that it is a small dining table? It's also made up of the same, but it has ready. Now, after 50 years, the study table also becomes damaged. You convert that into small table. Then you can't say that it is a small study. And after that, again, it will become. So, from dining table, it has reduced smaller size. Maybe after 50, that stool may not be working. Throw that. Means you are labeled the instead of that dining table, to the dining table, everything. That is how exhaust. Big mountain is. So hence, how different names given. Hence, we agents of denudation, landforms associated, refer them as erosional landform, and whatever they have eroded, they will deposit. We refer them as depositional, erosional landform, depositional. That is where UPSC asks in prelims, what are erosional land? River, what are depositional or wind? Can you give any one example of erosional landform? Valleys, alluvial, depositional, river valleys, potholes, gorges, canyons, river terraces, refer them as depositional landform, deltas, then embankments, floodplain, refer them as. This should be every agent of denudation of erosional land. You don't have to depth analysis. You have to just for what are erosion. Every agent of denudation. For example, talk about groundwater. Now stalactite, stalagmite. Have you heard about the name? Stalactites, stalagmite. Now stalactite and stalagmites are erosional landform or depositional? Depositional landform of which agent of denudation? Groundwater, and these groundwaters are also as karst land. Refer them as karst. They may ask, the stalagmites and stalactites are the landforms created of denudation by groundwater, and this is but karst land, and the next will whether they are erosional landform or depositional. So you have to segregate that. Till time is there. Segregate them. Revise them. Problem. Factual data. Is that clear? No. What water agent and erosional and depositional landforms create of density. Get that in fundamental class level. When you are reading, take a second. That will become your data. What you are. So this is some rough idea. Data technology. Discuss that. But before doing this, before moving, we have something called as evolution of an. Some questions. Now, when we talk about that, we refer that as cosmology. Refer that. How do you define cosmology? And what terms are associated? Galaxies, for exam point of view, not for general. Now, when you talk about universe, what is it? Past. Age of universe. So don't get afraid. When next year you will back with it. Age of universe is somewhat 14 billion years, approximately. Approximate. Or more specifically, 13.7 13. Now, what is age of our system? What is age? What is age? Say we 5 billion. What is age of sun or 4.6? It means that after the universe, our system, after the our system, that should be that clear. Now, when we talk about this perspective, talk about some rough idea about something up. Now, which theory explains the formation? Most so Big Bang theory is the one which tries to explain formation. And according to Big Bang, the age of universe 7 13 point. Now, who proposed Big Bang theory? George. And it is contributed by many evidences. Say it is most and it is given by George. And many contributions like Hubble supported, gave evidence. Now, recently, there is a theory which talks about formation, and this theory is based on, refer that as string theory. String theory also talks about formation. Because as there is a development in technology, awareness, so they make modification. Talks about subatomic particle and all those. Just remember that string theory talks about theory based. The theory explains about universe and it. Is it clear? Now, what exactly is as an exam point? Not a general discussion. What exactly important for the prelims point? First. Okay, yes. Here, words are very important. Writing, vocabulary. When we say big, you can't say very dense. You can't say very more dense. Right. So there are some words which are and that defines nature of your right. So when we talk about Big Bang theory, according to the Big Bang theory, according to it says that there existed a point, and this point was having density, pressure, which cannot be calculated, and that we refer that as infinite. Infinite. There existed a single point, infinite hot, and always use infinite. And this single point is referred by a term clarity. This infinite single point. Let me ask a question. Singularity means singularity is infinite hot and dense point from which this is the theory which talks about formation. Big Bang theory tries to explain the formation. So it says that the singularity, single point with infinite hot and dense, underwent expansion. It underwent scattering, expansion, scattering, and this expansion and scattering was fraction of second, not even 1 second, less than second. Refer that as inflate. Inflate. Expansion, scattered, inflate. And this made the entire content of that singularity. This made entire singularity. And even today, the universe is, even today, that is basic part of what extra this theory, what extra important for our prelims point to understand. At the moment when the Big Bang occurred, as it was having high temperature and density, the entire content was the fourth state of matter. States of matter, solid, one is liquid, third one is, what is the fourth? Plasma. Plasma arcs. Plasma means high temperature. Entire thing was there in the plasma. Entire thing was plasma. Now, when there is a plasma state, you don't find atoms exist. Everything is. So hence, it was like a fog-like structure. But as it expanded, the temperature decreased. Anything when it expands, the temperature. So because of expansion, its temperature. Now the moment when the temperature decreased, was rest for creating subatomic particle. Have you heard about quarks? Subatomic, lesser than atom. This was responsible for creating subatomic particle. Subatomic, for the mass and electron. And these are referred as building blocks of matter. Building blocks of matter combined and create something. These are referred as blocks of subatomic particle, quarks and electrons. These subatomic particles, quarks, then they combined, subatomic particles, quarks organized, combined, and these quarks, when they combined, they formed something called as and combined protons and protons and neutrons combined and formed the first electron. There was electron combined with after some, and when the nucleus combines with the electron, combines with the what it creates first at first atom, and this first atom of universe and hydrogen was the first atom. And here understand nucleus combining the electron. We don't know that whether it is first time or exists. We don't have any idea. So hence this event is referred as epoch of recombination. This event is referred as epoch of of that clear. Epoch of the terms which are significant. So after the Big Bang, up to this was completely dark, no visibility, dark phase, no visibility. So here we find first atom, hydrogen. Now this is called as epoch of recombination. Now during this time, photons escaped from the photons. Photons means first light was seen during this phase. Photons escaped from the plasma, and this photons which escaped from the plasma is referred as the first light after the first light of first light. What is the name given to this? Given to this? Have you heard about cosmic microwave background? First light called as cosmic microwave cosmic microwave. If they ask what is cosmic microwave, cosmic microwave background, first light developed after the Big Bang, after the epoch of, and this cosmic microwave background considered as an important evidence to support the CMB, cosmic microwave, referred as important evidence, support that clear. Good enough in science overlapping. Is that clear? No. So after that, when the first atoms were formed, they created the stars. Group of stars become galaxies. Then formation. So hence formed the first stars. Then the galaxies, star system. What the terms which are associated. That clear? Physics wala. Anything important of epoch of recombination, cosmic microwave background. That clear? That becomes the most important. And for this identify cosmic background, and its variation. They received Nobel Prize for Physics for identifying changing characteristic of cosmos. That clear now? So this is some rough idea about Big Bang. And according to Big Bang theory, the age of universe is 13.77 or approximate 8, or generally we say around 14 billion. Generally we say around 14. Clear now? Something about Big 7.4. When we talk about the Big Bang and these, now next question is, what about the universe and what portion is, what about universe and what portion is? Now whatever data we are having, what percentage of universe is known? What percentage of universe is 60? Okay. Whatever data we are having about the universe, 5% of universe. Only 5% of universe, based on our physics, based on our mathematical calculation, only 5%. What is bulk of universe consist? Any guess? Have you heard about dark energy? Dark energy and dark matter. Dark energy. Dark energy, which is carrying 8% of dark energy, carries 6. So this dark energy do not emit any, no light, no electromagnetic. Dark energy do not emit no electromagnetic. And what is the role of dark energy? Gravitational energy. Dark energy, gravitation, holding the, only these terms are consolidated. Now when you read any theories, you always find one is holding and one is repulsive, and within that universe is balanced. Within that universe, one is gravitational force which is holding, and one is repulsive, trying to pull. And which is that repulsive? Called as dark. That is dark. Remaining is dark matter. So this dark matter makes around remaining 27% of the universe. 27%. And what is the role of dark matter? Repulsive. And this is and expansion of repulsive or expansion. That clear? 5%. Because these are all in the new. They may ask dark energy. And that clear. Now two evidences regarding the Bang theory. One is cosmic microwave, and second evidence will be Doppler red. Second evidence is Doppler. Have you heard about Doppler redshift? What is relationship between frequency inversely proportional? Frequency is wavelength will be. Frequency is inversely proportional, and that is also solar radiation. Solar radiation spectrum, which consists of visible light, and visible light consists of your violet light, Vibgyor. When we talk about Vib or Vib, so they all are arranged based on the patterns. Based on the pattern. So here, when we talk about left side, they have high frequency. They are having high frequency. And high frequency means less or low wave. And here we are having low frequency, or they are having high or long wave. Now, if you take an ambulance and you are standing here, if the sound of ambulance increases, then what you conclude? Ambulance is approaching or moving? Approaching it. If the frequency of object increases, that it is approaching. If the frequency of object is increasing, it means that it is yes or no. If the sound of ambulance is decreasing, that it is away. Now here also they are arranged in. If you take white light, and the source and your observer. If the white light is approaching towards you, then its frequency should or decrease. Increase. If its frequency increases, it means that it should either become ego, you, or if it is moving towards. Right. If it is moving away from you, then its frequency should decrease. So in that case, this white light should resemble something like orange, red, so etc. So when you see the stars, what is the colors of the stars? Are they violet, orange, red, or yellow? Orange. What does it mean? Stars are moving towards you or moving away from you. That is called as Doppler's. Is that clear? So these are the two evidences. One is cosmic microwave background, and Doppler redshift gives an idea about expanding universe or contracting universe. Expanding universe. The stars are moving, it means that they are Doppler's redshift, what expanding of. That clear now? So hence Big Bang theory talks about all these two evidence, cosmic, microwave. So this cosmic microwave background is low intensity. When you are having old camera, you can't have clear picture. Now, if you want clarity on the picture, megapixels should be added, you will have more clarity. So Hubble telescope was unable to get more clarity on cosmic background. Now we have replaced Hubble telescope with more updated, which give more clarity on, name that, which is James Webb. Maybe this James Webb more insight on low intensity cosmic microwave background, which may give more idea about. Is that clear now? James Webb telescope, the key now. Now it is working very well. It is sending many data, and by which we are concluding many about. Along with that, many satellites have been also missions, like the two missions which are already out of solar system. Voyager 1, they are already out of the solar system, reached to the interstellar. And apart from that, we also have many, right? So many missions are there. Takes a few insight about. Hence, this data is not static. The more data we get, the more enlightenment, the more guide. That clear now? This is some rough idea about universe changing data, or more revival data is done when we are having more advancement. So next, we move on to something which is very relevant in the context of your study. Generally, we refer that as the sun or the. Now, before moving down to this, how to understand about stars. Now, the stars were formed somewhere after the epoch of recombination. Remember that. After the epoch of recombination, first become transparent. Transparency means now we are everybody. So after that of before that everything dark. Now the universe has become transparent. Universe has become transparent. Now when we talk about the stars, so the stars which are there in the solar system or in the, do you think that all the stars in the universe are of the, just like how the stars are formed? The first star was formed. The first stars were, now these stars, they always have the energy which is inside that. Refer that as their energy. Now which two, who's there to create? Hydrogen. Hydrogen is lighter or helium? Hydrogen is, helium is. So in the nuclear energy, hydrogen combines or helium? Fission is different. Fusion means the energy which is produced in stars is called as stellar energy, which is fusion. Here, so here in the context of star, here fusion, where the two hydrogen combine and they form the heavy called as, which is for developing tremendous amount the form of radiations. Refer that as solar radiation. Right. Now it's just like petrol in the vehicle. Now you are having a vehicle, suddenly 5 liters of petrol. Now suddenly when all the petrol ends up, fuel ends. So here also these stars are performing their fusion, means they are having certain, and the fuel here is, hydrogen. Now when the complete fuel ends up in the stars, that is called as, and this death of a star is not a normal one. We refer that process called as supernova or explosion. So death of a star in general we refer that as nova or supernova. Or the moment when you use the term supernova, it means that explosion of a star. And what does supernova indicate? Supernova indicates death of a star. Now this, all the stars, do they have same amount of fuel in them? Some may be more. That clear now? So these stars will undergo supernova, and then the ejected material combine and form. This is how the new stars are formed, and this star will also undergo supernova, and one more star will undergo super, and then new star will be. Now, how do you identify that as an old star and the old star? They will be having poor metal composition. They will not be having old stars. Stars having poor metal composition, and we refer them as Methuselah stars. Poor metal composition. How do you identify the stars? Young stars be having denser core. Denser stars will be having denser. They will have more amount of carbon. They will have more amount of iron. More iron, more carbon. So such denser stars or recent. So hence we have the stars which are having the age from 13 to 12 billion. Now, by calculating the density of, calculated the age of the sun as, by calculating the composition of its core, the age of the sun, which is star of solar, 4.6. That's how we can that it. Is that clear now? So all the stars, they have certain life, and after that they end up there. Right. Now, in the same way, when you talk about end of the, so here also we find human beings also we find some die natural death, some because of accident, some because of. So in the same way, the death of the stars is also defined by a criteria, and this criteria is given by Indian scientist has given a criteria which defines the death of Chandrasekhar, and we refer that as Chandrasekhar limit. So the death of a star is given by a limit called as. Now, what is Chandrasekhar? Chandrasekhar limit value 1.4 times mass of 1.4 times mass of a right 1.4 times, and here he says any star which is less than Chandrasekhar will end up life in the form of dwarf star. Will end. So any star which is more than Chandrasekhar, more than Chandrasekhar, more than Chandrasekhar, bigger than 1.4, then it will end up either it will become a neutron star, rotating star, fast neutron star, or will end up the form of black. End up. Clear. So internal collapse of a star is given by which person? What is that value? Chandrasekhar. 1.4 times mass of any star below the Chandrasekhar die in the form of dwarf white dwarf. Any star bigger than Chandrasekhar, more than Chandrasekhar, die either in the form of or the form of black. Clear no? So this is some rough idea about. So hence, at this stage, we stars in the universe are of different stage of their life, different age of. Some stars are old stars, some stars are that clear. So hence, the stars in the universe are not of this. They are of different age and different of their. That clear no? And among them, we say sun is young one. May say somewhere in the middle of its. That clear? Some rough idea about Methuselah star, first beginning star. They generally take the criteria of the ratio. Ratio means here the main component is hydrogen. The ratio of hydrogen and ratio is taken, and this ratio defines whether the star is star old. That clear? Basics, the context. That clear? Now, when we talk about the stars and all, more specifically down to sun. Sun is a star of solar system. Sun is a. Now, in the sun also we find by a process called as by of nuclear. And when you talk about the nuclear fusion, the core of the sun, hydrogen combining and providing huge of radiations from magnetic. Now, the moment when you talk about the light of the sun to the earth, how much time it takes? 8.2 seconds. 8.8 minutes and now when we talk about sun, generally when we read in the geographical perspective, we find the sun in rather than core and interior. After that, we have the first layer, we refer this as photosphere. Surrounding the photosphere, we are having chromosphere, and surrounding the chromosphere, we are having the third layer, corona, layers of the photosphere, chromosphere, and this is. Now, which part of the sun is visible all the time? Whenever when we see which part of the sun all the time, the photosphere is always photosphere part which is now when the corona is visible, when the sun is covered by moon, sun is covered by sun on one side, moon and earth. This is referred as which phenomenon? Solar eclipse. So during total solar eclipse, corona is only total solar eclipse. Corona is during total solar eclipse, corona is. Now here we find nuclear fission takes and energy moves. Now my question, you are having source of a heat, you are moving, so the temperature when you are moving away from good. Now which is the hottest part of the sun? Photosphere. The corona is highest. This is something which against the something which the hottest part of the sun. Hence, you can see the photos. Corona is visible only when it is blocked by the present. Is it clear? The hottest part is it is against the general belief that when you are moving away from the source, the temperature decreases rather than increase. And hence that is the reason we are making effort to study in detail about photosphere corona. That is where two missions are there. One is Parker probe and second one is mission Aditya, launched by there are two which are making their effort to study. One is NASA's Polar Parker of NASA, and second one is the mission Aditya of mission Aditya. What are their main objectives? Study the photo chromosphere and why corona is more hotter than that. There has to be some reason. Some say it is nanoparticle. They have given that nanoparticles from photosphere corona, then they burst. That is where the temperature. But we don't know exactly. At present, that nanoparticles from the photosphere, they move out of that region. They reach to the corona and then they burst. When they burst, the temperature by default increases. But we don't know exactly whether these are nanoparticles or something extra, which is hence the two missions tries to explain this perspective of here no photosphere, chromosphere, visible part is for, and to study that Parker probe and what happens sun. We always come across the sunspot, and along with that, we also have something coronal mass. Coronal. What is sun? Coronal mass? Very significant, but yet important in how the sun. You may have the sun having maximum sun and the sun not having any. So sunspots are permanent or temporary. That should be. Sunspots are temporary. Means they indicate some phenomenon. Temporary means. Now, which portion of the sun will have the present? They are present. Sunspot. Is it clear? What exactly is the sunspot? Are the dark patches? Sunspots are nothing dark patch. Dark patch. Now, the energy which is produced in the sun is in the form of electromagnetic radiation. So, hence, by definition, sunspots are nothing but intense electromagnetic flux or intense magnetic flux. Sunspots are magnetic flux means magnetic pressure which consolidates. So sunspots are intense magnetic flux. Now, if you see the temperature of the photosphere, if the average temperature of photosphere is 1000 degrees, the average temperature of photosphere is 1000 degrees, then the temperature of the sunspots will be 4000 or 4500 degrees. The temperature of the sunspot 4500 or 4000 degrees. So compared to other areas, they look like dark parts, black spot, because of intense magnetic. Now, why they resembles black? Something like you are having a balloon, all the area the water is. When the water is falling, if you put balloon in that, all the water will the balloon, all the water will fill the balloon. So the concentration of water in the balloon, but not on other side. So the magnetic flux will increase, accumulate in this. And the person who is beneath here will find that as intense magnetic flux which has accumulated. But the major problem is this magnetic flux which has formed will not allow the radiations to pass and just like balloon which has stopped the water. So when it has stopped the water will not reach. In the same way, magnetic flux which has accumulated in it will stop, will inhibit the sun's energy to pass and reach. So hence, it will accumulate the energy inside, but from the people who are staying on the earth surface, for them it looks like dark. But within that, has it accumulated huge amount of energy? It has accumulated huge amount of energy, but for us who are staying on the earth surface, for us it looks like, but within that it has stored huge amount. Within that it has stored. Now, balloon has stored water. It is just like a knot. Now this energy or this water which is stored in balloon is not permanent. When the balloon bursts, what happens to the entire water? Now in the same way, entire energy which is stored in the sunspot, when the sunspot breaks, then what happens to the entire energy? Reaches to the earth in the form of high energy. And these energies which are reaching from breaking up of the sunspot, we refer them as coronal mass. So when these sunspots, which are temporary, when these sunspots they break, when they break, they release a huge amount of energy. They release, and this energy which is referred as coronal mass. Coronal mass. Now, whenever sunspots are there, means that they will have a huge impact on the. Now, when the coronal mass ejections are there, means that high charged particles are reaching the earth. High electromagnetic charged particles are reaching. Now, when these high charged particles are reaching the earth, then threat to which part of the earth? When coronal mass ejections are there, will affect which part of the earth? Artificial satellites will be having a communication will be having a navigation will be a problem. Is it clear? And these solar radiations, they are protected by Earth's magnetic field. Earth has a magnetic which protects solar charged particles, coronal mass. Is it clear? Sunspots are temporary phenomena, intense magnetic flux, and are temporary phenomena, and they are always developed as a temporary base. And when they burst, they release tremendous amount of energy, and we refer them as coronal mass, which becomes a major threat to life activity. And of course, the Earth is protected by magnetic. No, some rough idea about. Now, what is the exact reason behind the very brief way? Is very relevant. To understand, bit complicated, but yet sometimes when they ask you, rest of the things you get in the textbooks, but these are overlapping with SNT, overlapping with affairs, overlapping with geography. All four things are included. Now understand this. Now, when we talk about the temperature inside the sun tremendously very high, means it is the form of plasma. As it is in the plasma state, so we find the nuclear energy is responsible for moving and collapsing of the charged particles, which collide. The movement and collision of the charged particles and collision of the charged particle, the sun's plasma, it will create a process called as dynamo mechanics. Refer that as solar. Just remember, solar dynamo. And this solar dynamo mechanism is responsible for creating strong magnetic field for the sun. So this solar dynamo mechanism, strong magnetic So it means sun's magnetic field is limited to certain area. Sun's magnetic take the sun. will have its magnetic up to this region. Refer that as heliosphere, sun's impact. And after that, its impact will be less. After that, another star, and this portion becomes interstellar for this. Interstellar for then, and every sun will have its magnetic, and this is solar dynamo mechanics, and this creates the magnetic, the context of. Now this magnetic field realigns it, because if it keeps on in the same parameter, there is possibility that the magnetic peak. So this magnetic field realigns it, by reversing it, changing its polar, something like you are having as a north. When it changes its polarity, you are having, keep this as a thread. Now bring the one part of thread downward, other part of thread. When you do that, in the central portion, it will develop a knot. When the sun changes its polarity, it will develop a knots. And these knots are nothing but dark spots. Refer them as. So sunspots are the results of magnetic reversal of sunspots are the result. Magnetic reversal. That clear? Sunspot. It is reversal. When the north moves and south moves, temporarily the knots are. And when these knots break, we have something called. So hence, CME is coronal mass ejection. Knots snaps. Suddenly, when these knots break, the energy which refer that as mass. Now, this magnetic reversal phenomenon is not haphazard. That's why sunspots will occur. And this reversal, this magnetic reversal of the sun, organized, and it is periodic. Periodic means fixed, and this will take a cycle, which is referred as 11 years. In 11-year cycle, average 11-year cycle, sun's magnetic polarity, north becomes, and within that, sunspots are created. Sunspots. How? I'm talking about the bar magnet, which by this. Only the bar magnet's polarity aligns with different. The Earth also magnetic polarity change. I'll explain. Focus on this. Earth's magnetic different from. It is maintaining the strength so that the is the process, the alignment by which it is inbuilt mechanism. All are in the of. When you talk about that, the core you are having high, and then that creates something called getting huge. Have in the don't get in. Optional, you may have to dig, but here sunspot cycle. Sunspots are the result of magnetic of the, and this is always seen once in. Now, if they say sun's magnetic reversal periodic or non-periodic, periodic, and it is always cycle of and always cycle of 11. Is that clear? No. So when you are reading current affairs, you are reading, have started calculating the sunspot from somewhere around 8. And these sunspots were first identified by Galileo. First identified Galileo. At present of 2020, we are in the 25th cycle. Refer that as 25th cycle from when we calculate. So at present, cycle is 25th. Okay. So here, when we talk about it is a large elaborated process, more amount of engineering person, but just prelims, long time. Just understand sun's magnetic of solar depth. In prelims, that is more. Prelims, that is, they will never ask you how it is. Just remember. And the associated magnetic coronal mass ejection, 11-year cycle. Is that clear? No. And at present, we are in that. Refer that as 25 means 25th cycle when we started calculating from. And every sunspot cycle is 11-year. That clear? Some rough idea about? Here, prelims class directly based. The process which is 4 times, but that is not terms. Focus on sun and its other. Now we move on to solar system. Now when we talk about the solar system consists of how many planets? From 2006, National Astronomy consists of then plus like gases, dust particles. Now the moment when you talk about solar system, before 14th century, it was referred as geocentric or heliocentric. In the beginning, it was referred. So what does it mean? Earth is in the center, and sun and all other planets are revolving around. That is called as. Now with Renaissance, improvement in science, Copernicus persuaded that it's not geocentric. Geocentric. That is, sun is. All other planets are revolving. So that is called as. That is, sun is, and all other planets are revolving around. That is general perspective. How exactly mine? How exactly as NASA? When we talk about Earth's revolution, it same path. Now, recently talk about something called as Barry center. Barry. At present, we solar system Barry center. Very special. Very special. Barry center. What do you mean? Sharing. Sharing. Anybody from background? At least class 12th science. No, not that. Barry center. Here, talk about Newton of gravity. always a force of attraction. Now, barycenters, two bodies all revolve around along their center. Two bodies always rotate or revolve around each other along their bodies. Always rotate or revolve around their. If you are having a scale, to balance a scale, center of mass will be the scale. Center of mass is, if you take a hammer, if you keep it in the center, will it balance? Now, where its center of mass, where the iron, hold that, balance will be. Now, in the same way, when you take the sun and earth, sun and earth, sun is big and earth is comparatively. So, when we take the center of mass between, it is not outside. And for us, it resembles like the sun stagnant and earth is revolving around. Sun is also revolving around its mass of center and earth is revolving around. Refer that as. Now, this center of mass, is it same for all the planets? Varies from one planet to. Now, for earth, the barycenter is, maybe for Jupiter, it may be outside the sun. For Jupiter, outside. But for the sun and earth, something like you are having the barycenter, and here you are having the earth will revolve around this, and the sun will also revolve around. So, this is how particles or the planets of our system, and more specifically, hence we all the planets in the solar system are all the planets in the solar system. So, we move from so, and the present. If something comes barycenter, mark it, barycenter, any two objects, all the planets. Mercury is still smaller, so barycenter. Also revolve here, revolve around. That clear? Talk about the solar system as per the. That's why when the Earth is revolving, can we have a particular path? That's why we Earth is revolving around. Because this keep on changing. Sun is also changing. Earth also. Is that clear? So hence we more specifically, even though in NCERT we path of revolution of the Earth around the Sun is elliptical, but more specifically, generally, and more specifically, irregular. Why? Because of barycenter. That's why when we read more technology, is that clear now? This is the present aspect. Now, when we talk about solar system, what are the planets? Talk about the sun. Now, the starting 4 planets, and then we are having the. Now, which is the largest planet? And these starting 4 refer the mass. Or inner planet. They are solid in nature, having more density, solid. And these are referred as Jovian planet, outer planet, less denser, gaseous, less dense inner planets, Jovian planets. And here these are divided by a belt for the mass asteroid belt. So asteroid belt separates terrestrial planets from Jovian. This is also called as a great divide of solar. Asteroid belt is also between which two planets? Mars and asteroid belt. Or it separates the terrestrial planets from Jovian planet or outer planet. Is that clear? Asteroid. Now, asteroid belts, the moment when asteroids are referred as left out particles in the solar system. So hence asteroids can be referred as fossils of the asteroids are referred as fossils of planet. Now, what is the region which beyond the last planet of is the last planet of right? So here you are having and which is the largest object of the dwarf planet called as the Kuiper belt. We are having dwarf planet, asteroid. That clear? Largest object is the Kuiper. Some data which are something which are right now. When we talk about asteroid belts and talk about these, so these asteroids, they are referred as fossils of. Now, along with asteroids, we also come across certain parts of certain group of asteroids. Refer them as trojans. Heard the name? Certain asteroids, we refer them as trojans. It is something like asteroids are common. Within asteroids, we are having certain asteroids which are referred as. Within asteroids, we are having certain asteroids which are referred. Hence, trojans are asteroid with certain character. Trojans are asteroid with certain character. What is that certain character? So the trojans are asteroids which move along the planet, with the planet in their orbit without riding with them. Such asteroids we refer them trojans. Greek, when the king is moving, they are having two bodyguards are there protecting the king. Refer them as trojans. One trojan. In the same way, take this planet. There are asteroids which are, but certain asteroids which are moving along with the planet in their planetary path without colliding with the planet. Such asteroids we refer them as. So trojans are also asteroids. But how they are different from the asteroid? Asteroids are moving in this path. Separate belt is there. But some asteroids which move along with the planet in the planetary path along the sun, but they do not collide with the planet. Such asteroids we refer them as. When they do not collide with the earth, with the planet, it means that they are like parking slots. They are balanced one, parking slots. So these parking slots, generally in the solar system, where they balance with, refer them as which point? Aditya, when we say Aditya is kept at one point. No, geostationary there. But what is that point? Lagrangian point. Lagrangian. Every planet will have, or every part will have 5 Lagrangian points, L1, L2, L4, and so these trojans will be traveling in Lagrangian along with the Lagrangian without colliding the. So such type of asteroids we refer them as. Now, which planet will be having more trojans? Obviously, and hence to study the trojans, already NASA has set a mission. Trojans. Lagrangian means balancing point. You are having an Earth. Two objects are one object, right? Now, anything you want to make, you have to check the gravitational pull of these. You can keep an object, you can balance in between without having force. You can keep somewhere here. You can keep an object so that the balance will be, or you can keep the object. One possible. Another 2 points is somewhere here. For that parking slot. Aditya L1, like here we have keeping in between the L1. Aditya L1 means Aditya will be parking slot. Because these will have an gravitational pull. So within that you have to balance that. It's something like you are having two bodies, you have to balance. If you are balancing here, you have to use much energy. But if you are using forces without spending much, that's how the Lagrangian. Parking slot without spending of energy. So here also those are called Lagrangian. Now such trojans are very simple. And these trojans will give an idea about outer planets. And to study that has been to study asteroids. More specifically, that clear. So when they ask the statements, all the asteroids are trojans. All the trojans are asteroids. The difference is trojans are moving along with the planet, but without colliding with the planet. They are always traveling with Lagrangian. Which one? No, they don't collide. Which asteroids? They are already balanced. Asteroids, they may collide, but not these. Moving asteroids can. Very rarely you not trojan. Not already, you can't say that they will not hit. Possibility may be there. Possibility, but you can't say that more possibility of Lagrangian. Are the difference between the clear. Now coming back the terms which are there in the news. Now Earth do have any that is where if the question is asked natural satellite. Earth have to combine. Earth have to, and they are just make 2010 untrozen and 2020 XL. Sometimes when they ask 2020 XL5 is trojan of not asteroid. Trojan. What is trojan? Part of a asteroid. Also, that clear now? So maximum asteroids or maximum Trojans are along which planet? Earth has to identify. They will be having, but now they are discovered. Here we believe they have been identified. Every planet will be having, but now they are. Now don't confuse that with natural. Now which planet has maximum satellite as per the International Astronomical Union? Which planet has maximum satellite as per International Astronomical? Okay. How many satellites are there for Saturn? According to National Astronomical Union, Saturn has 200 and has overtaken. Now the maximum highest number of satellites. Recently, they have identified 120 moons. At present, the planet which is having maximum number of satellites, Saturn, having 207. Clear, not Jupiter. Now, which is the largest satellite of largest? Titan. Titan is the largest satellite of, and which is the largest satellite of entire solar system. Don't get confused. The largest natural satellite of the solar system, Ganymede of Jupiter. Ganymede is the largest satellite of Jupiter. Saturn has 207. Within these 274, the largest one is, so Titan is satellite of Saturn, and Ganymede, the satellite of Jupiter. The largest among all the satellites is Ganymede, and largest among the satellites of Saturn is, match the following. Match. That clear now? The terminologies. Now, which among the planets are referred, terrestrial planet are referred as largest? It's clear now, this portion. Among the terrestrial planet, largest planet is now. If you take the position of the Earth, the distance of the Earth from the Sun, it is such, the temperature is not very high, and temperature is also not very. When the temperature is very high, then there is air, water will. If the temperature is very low, then entire water can convert into ice. So hence, its distance is such that the temperature will make the water in the much of the water in the distance of the Earth from such that the water is in the liquid. What is advantage of this water in? The advantage of this, if the water is in liquids, then it is having possibility. Other two factors are magnetic and the composition of atmosphere. So three things are responsible for life. One is protection from the harmful solar radiation, magnetic. Second one is composition of atmosphere, breathing air, water. Right. And the third one is water in the. So these are three. Among these, the water when it is, which is having the possibility. And hence, this condition, where the water is in the liquid, where there is a possibility, refer that as Goldilocks. Refer this as Goldilocks. So the moment when we say Goldilocks zone, Remember that Goldilocks zone, the solar system where the water is, and it is having possibility of life. Does not mean that life exists. Possibility, because the atmosphere may, their planet atmosphere may not be suitable, but the water is in such areas we refer them as Goldilocks zone. Earth is where, along with magnetic field, composition of atmosphere. That clear? No. Are some important aspects. Largest terrain. And Earth also have its magnetic. Earth has its at late, but Earth magnetic, which protects the Earth from harmful charged particles. That clear? We have something called as meteorite, meteor, and meteorite. Are the three terms different from each other? This is the Earth. Objects which are spherical, we refer them as planets. Smaller than that, we refer them as asteroids. In the same way, smaller than meteorite. So celestial bodies are smaller. No, all meteorites will not reach to. Some meteorites, when they reach to Earth, has its own atmosphere. Earth's atmosphere. Now, the moment when this meteorite enters to the Earth's atmosphere, meteorite starts. This meteorite starts burning. And this burning meteorite, we refer that as burning meteorite. Meteorite will become burning meteorite. And it burns because of friction. Right? Starts burning because. Now, this meteor may be due to composition because of size. It burned completely, or unburnt meteor can reach to. Now, when the unburnt meteor reaches, we refer this as right. Meteorite burns, and this is also referred as falling star, or meteors are referred as falling star, or and unburnt meteor, when it refer that as. Now, composition of meteorite will be almost all same like that of an Earth. So hence meteorites can be referred as evidence to study the Earth's evidence to study the direct or indirect. Meteorites are referred as indirect evidence. Meteorites are direct. Study the Earth's because the composition may be same. Indirect evidence. Is it clear? Meteorite, your stars, or right now, in which layer of the Earth start burning? Troposphere. They are having mesosphere. Meteors are seen mesosphere. Is it clear? No. Meteorite. Here. Now, these meteorites or asteroids, when they collide to the planet, they will have something like a big rock and throw on the surface. Get a bowl. Meteorites are big one. Now, in the same way, meteorites or asteroids, when they collide to the Earth, they will create bowl-like depression. And these bowl-like depressions are the So these meteorites or sometimes asteroids, when they collide the Earth, they create bowl-like structure, bowl-like, bowl-like depressions. And as they are created by asteroids and meteorites, we refer them as high velocity impact, high velocity impact, impact. And these high velocity impact craters, in geography, we refer them by astro. Geography, when we read, what are astro? Geological high velocity impact of Earth, or problems are geological, geological high velocity impact later on. And these astrobleams, they are responsible for formation of certain lakes that are there in the. And in India, we are having 4 astrobleams which are very well, 4 very well present. Astro, the first one which is very famous, Maharashtra. Have you heard about Lunar Lake? Lunar Lake is, Lunar Lake is man-made fact of Lunar Lake in Lunar Lake. Apart from that, Ramgarh, Ramgarh, Ramgarh Lake, and then Dhala Lake, Madhya Pradesh, Dhala. And recently, identified one more crater, one more lake, the state of Gujarat. We refer that as Tuna Lake. Tuna crater. If they ask, Tuna crater, Ramgarh crater, Dhala crater, Donar crater, all are lakes, but they all are created high velocity. And we refer them as. And this Luna crater is in the largest grassland of Asia, where they are thinking translocate the African. Have you heard about Bunny grassland? Bunny, Bunny, that is a grassland. Bunny, lakes can be by endogenetic force, man-made, by rivers, they can be astro. You may ask, right, some idea about asteroids. So next we put on to something called as latitude and longitude. So another 5 or 10 minutes of Many questions are asked on the latitude, longitude, and sometimes when you talk about the term called as the day and night, every year you will find. What do you mean by latitude? They are the imaginary lines that are drawn east and west and north and south of globe, globe or the latitude are the lines which are drawn, and longitude are the lines which are imaginary. Many students are confused. When you talk about the latitude, they are always expressed in angles. These are the angular distance from the center of the earth. Angular distance from the, this is an earth, 5 degree, 10 degree and half, 90. If it makes 60 degrees from the center of the line, which will 30 degrees, well, it has. If it makes 90 degrees, so hence latitudes and longitudes are angular distance, center of are angular distance. Center of earth. Angles, they are always represented 5 degrees, 90 degrees. The same way, longitude. And these longitudes are always presents the places. They are used to locate the places on. Try to answer. Latitudes, the location of place. Latitude, the location of place. East and west or north and south. Latitudes, north and south of equator. Longitudes are used to locate the place east and west of major. Even though the latitudes are drawn east, but the latitudes are used to identify the location of place north and south. Always understand. Latitudes are drawn east and west, but they are used to identify the location of north and south of. Hence, we are having northern hemisphere. Latitudes always north and south. Don't have east. They will always be north and take India. India is located in the northern hemisphere. It means that take the latitude extent of India. Latitude. You can't say this is north and can't say one is north and one. Both are in the and this is angular distance 6 degrees from the equator. So hence India is located. So we refer that as equatorial distance degrees, and this is 30 degrees. We take Tropic of Cancer 23.5 degrees. Will make half degree. So hence India is located. So latitude shows the location of place north and south of, even though they are drawn. What about longitude? Longitudes always show the location of place and west 5 degrees of meridian. Now understand. They are called as meridian. All the longitude are having same length. They cut the earth, all the meridian. But among the latitude, which one is the largest? cuts the earth into, and hence this equator is among the latitude only one great circle, and among the longitude all the longitude every longitude cuts the earth into. Among the equator only, sorry, among the latitudes, is it clear? So hence north. Now when you combine latitude, longitude, combine latitude, get a grid, and that is cartograph. Find them. Now, if you take latitude and longitude, which imaginary lines are equal? Latitude are always parallel to longitude are having maximum distance at the equator, but at the poles merge. At the poles, and the point where they merge referred as north pole, and the point where they merge we refer that as geographic pole. Refer this. Don't confuse this with magnetic. When we say Earth's magnetic polarity, geographic north pole will not. Magnetic pole. Geographic poles are fixed poles. They will never change. Geographic poles are fixed. They are permanent. And these are the areas where the longitude have merged. These are the areas they are fixed. Latitude. So for every 1 degree distance of the latitude, will travel 111. For every 1 degree, 100. Now, is it same for longitude? Maximum at equator, and the moment when you move on to that, that's why here it is. Hence, speed of rotation maximum less, travel more distance. Is it clear? For reading that, please, of latitude can also be of latitude north south, the same associate maximum at the, and when you move on to the merges. Is it clear? Have a break of 15, and again we'll latitude